Okay, so let's continue the lab part. So now, if you guys look at right, so there are certain inputs that we would actually need. Okay, so all that, say for example, you have got your Verilog netlist and your SDC and your floor plan dev and your all of that, and then libraries and all of that. So the first thing that we look at is say import design. Okay, so the import design. So this is what we call it as a script. Now, what is the meaning of script? It's basically a collection of commands that you wanted to have it in the tool, or probably the tool to do. So one after other. So the tool would actually, kind of say creating the database, create lib, and then say read verilog, and then you kind of set your multi-mode multi-corner where you define your PVT, the timing corners, and then you would define what corners you wanted to pick it up and SDC and all of that, and directions for each metal layers that you would set it up, and then what layers you are supposed to use for routing and all of that, and then say sanity check. So this is what we were talking about it. So any inputs that you get, you would actually definitely need to run your sanity checks. So check timing, check check netlist, check timing, and then you've got your zero wide load model timing. Okay, all these you are supposed to run. Okay, so now the way the industry works is nobody is going to sit and run or one by one. So there are certain things that put together and we would be just running them, and end of it, right, end of the things, we would have, say once you complete your import, your design, when you open your design in the tool, it would look like this. So in this, if you look at, right, say these are all macros are kind of big cells. uh, they are designed for certain functionality, and all your standard cells are sitting over here. It is just, you have just loaded all your things. Okay, so you have not done anything now. So this is your input output ports. Okay, and then if you look at this all, okay, so you have got around 52K cells, right? So all your cells have kind of are just sitting at 0 0 without any kind of physical area assigned and all of that. Now the next step we discussed, right, so you need to assign a area. Okay, and that would actually and then you need to place all your macros and everything. Now look at this. So this is your area for your block. Okay, so this is your area. So now how do you create this area? So now what calculations that you need to take care? So is this area is going to be good enough or is it too much? So how do you assess that you are actually taking care of the, or looking at the right area and everything? So we do die size calculation and then channel calculations and then place them, whether you can rotate these are all the macros that we were talking about. So these are all SRAM macros. So SRAM memories. So uh, different sizes. Okay, and then now if you look at here, so we kind of initialized your area, and then your macros are kind of placed in the core area, and then we also have done your power routing. So this is your power routing which we have done. Okay, so how your standard cells and macros gets power. So this PG hookup is also done at the part of floor plan. Okay, and if you look at your standard cells, so all those 52K cells were sitting at the down. Now see here, they are all sitting still here. We have not placed them internally yet. Only the big cells we have kind of placed, and then these are all your IO ports that we have kind of placed it. Now how do you place these IO ports, what precautions that you need, all of that we will actually take care during the floor plan itself. Okay, and now so this is on the floor plan, and then the next thing is, you the foundry brings up certain requirements, okay, to manufacture your chip properly and make sure it works. So we have to add something called boundary cells. So now you see here, these are all the kind of cells, okay. So you can see them here, right? See these edges, all these edges are, kind of, protective. So it's kind of, you're protecting the cells and all of that. So these boundary cells, so now if you look at, there are a couple of boundary cells that we need to add. Say one is end cap, okay, and then you will also have something called tap cells, okay, and then you also will have something called IO buffers. So you see here, so there are certain IO buffers that you add, okay, okay, and then we also have, say how you have a stepney in car, right? So the same way we will also have something called spare cells. So all these are all kind of spare cells. Say this kind of cells are used in the revisions. Say for example, we talked about A1, A2, and etc., right? So we use these spare cells to get these revisions done, okay. So spare cells, so these are all the cells that we add during, just before the placement, okay. So now this is kind of, we call it as a pre-play stage. This is something that we call it as a pre-play stage. So now what and all we have done, so we have checked, we have discussed. One is inputs, next is floor plan, and then pre-place, okay. And then the next one would be kind of, say, your placement. Now, if you look at your standard cells, all those 52K cells, where are they sitting? They are still sitting over here in the boundary, on the 0, 0th location. Okay. So now the next step would be placing them in the score area. Okay. Okay. You see here now, whatever the cells that were sitting in the 0, 0th location, now this all now have we brought them inside and then we placed it. Okay. Now, so how do you qualify this? Okay, so how do you qualify this? So now if you go and look at, right, so we have something like kind of, color by hierarchy, and then look at it. So is this kind of good placement? Now I see there are issues because, see, this green logic is kind of getting spreaded. Probably I would actually do some refinement and then look at if I can close, place them close by. Say this pink and this pink are kind of getting little split. So now how do you analyze whether the placement that you have completed or the tool have completed now, is it good to go, or you need to stop here and then correct some things? So now ideally speaking, right, I know seems like there are some IO ports that are kind of interacting with the macros that are placed over here. You know what I would do in this scenario? Pull these macros here. Probably this would reduce this logic spreading. Okay. So now these are all the kind of QA checks that we do and make sure you are having the optimum design. Okay. So in terms of cell count, in terms of power, and in terms of performance and area and everything. Okay. So placement, right? So now you look at your timing and your congestion and all of that. Okay. So see in this scenario, what I would do is report global timing. This would actually give me a quick update on the setup and hold status. You see here, it is kind of says that my setup is clean, and then it says hold violations, which I'm not bothered, okay, because we are not done clock tree building yet. So it says no setup violations found. We are good to go. And then you have something like, say, report congestion. See here now my congestion report, what it says there is some overflows, okay, and then there is some percentage, okay. I mean, it's kind of some numbers. So do I really need to be worried? Okay. So now how do I decide on this? So all this we would cover in depth, and then you would also see get utilization. So my utilization is basically 47%. Okay, so remaining 53% of my standard cell area is kind of unused. So is it is it like kind of good, or do I need to reduce the area? So to be honest, this is a kind of luxury life that we have here. So ideally, you are actually supposed to reduce your design size, say something like this. So 47 is something that I don't accept. So it has to be, since we have done with placement, it should be somewhere around 65 percentage. So now why I say that, and what is going to happen if you have more area and all of that. So we will discuss all of that, okay, when we get into that particular topics. And then, so your standard cells which were sitting at 0 0, now they were all kind of brought in. Now you are kind of analyzing in terms of timing, congestion, and then your utilization and all of that. And then the next step is to look at your CTS clock tree. Okay, so we would actually go and build your clock tree and see. Now the important part here is, so you need to check your clock tree QOR. So report clock tree, report clock QOR hyphen. Okay, so this is going to give me now, as I told you guys, right, the clock trees, whether I have got the, whether my insertion delay, skew, and all of that are proper or not. Look at here. So each of the corners, say in FF corner, and then say in my SS corner, what is my, how many registers are there for this clock. Say sys2x clock is having these many flops, and then number of levels, and then clock cell count, and then clock cell area, and your latency, and your skew, okay, and your wire length. So all these you would actually check whether they are in within the target limit or not, and all of that you have to check. Okay, so this is how you have to check in the clock tree. So mainly the insertion delay, skew, and your number of clock cells, and the clock cell area, and all of that. Okay, and then we would actually go on, the next step would be kind of say routing. So now if you guys look at this particular thing, so now say this is your kind of circuit. Now this is your net that is connecting this cell. So there is an output which is going to an input, okay, which is kind of AOI cell. Now this is the net, that's a logical net, okay. Now that logical net is kind of how it is kind of routed. You look at here. So we have used the actual layers. So we, if you look at, right, so we have a different layers. So M1 layer, M2 layer, via M3, M4, M5, and all these layers. Now, how this guy is actually routed. Now, see here, there is a via and then M2, and then see here, this is what layer you can just see here. So this is M3, and then it's kind of using the other layers and then routing it. Okay, so now let me just show you any other layer. See, for example, this particular thing. So you see here, now let me just dim this. You see here, the cells are kind of sitting over here. Now, see, this is kind of, say, this is kind of routed DB. Now, each and every layers have been used for routing, whereas this is your circuit. So logically, it's kind of, one cell driving one, two, three, four different fan outs. Now, this you see here, one, two, three, four. So all of them are kind of routed using the layers. Okay. Now, so this is something that we call it as a route. Now, so after route, what is it we check? We do check for, as I told you, we would actually check for zero, the number of opens and shorts. Okay. Now let's go and just quickly say this. Okay. Say check LVS. Okay. So this will tell you if there are any opens and shorts. See, it says here there are short violation. Basically, total number of shots are zero, and see you have a total in the nets. The logically there are nets that are kind of say 49K, and there is some open. So some VDD nets are kind of open, and floating is kind of say zero. So this is in terms of your routing QOR. It is number of opens and shorts. Okay, and then so you also would run your DRCs. So check routes. Now if there are any DRCs, so you would, this tool would actually report. So it is kind of checking full DRCs. So each and every stage we have certain goals, and then certain QA checks to ensure that we are actually meeting those goals. Okay, you see here total number of nets are 49K, and total number of opens and all of that. So it says total number of DRCs or GRCs. DRCs are basically zero. Okay, so antenna violation. So we have not defined anything, but we will try to define all of that when we do it. So so this is how you actually now go and check each and every stages. And now after this routing, what we do is basically, say there is something called extraction. So your spiff extraction, you would do it, and then you would run, say, something called STA using prime time tool, and then you would actually kind of generate ECOs if there are anything that is required for timing closure and all of that. So this is a kind of flow that we follow in industry, and you will also follow exactly the same things here. So uh, now if you look at, right, so I would be giving you a make files, make file based flow, so which is nowhere there, I would say, in any of the training institutes. So if you look at here, so this is kind of a readme file which would actually help you as a kind of lab guide, or the steps that you are supposed to follow. So import the libraries netlist. So what you need to do is say make import, and then say make floor plan, and then make pre-place. So you won't be invoking yourself ICC and then sourcing the scripts and all. So this is exactly what we do it in industry. So the whole flow was written by me. Okay, so the make flow. So you see here we finish route, and then we go for extraction, and then we run STA. Okay, using the PT, and then we run physical aware timing ECU generation. So we have DMSA utility available with us with the license feature and everything, and then roll in that ECUs and all of that, and then finally you keep running the other checks. So this is how we would be doing it, and then we also have certain how to do sections. See, how do you invoke your ICC2, how do you open the DBs, so now what else you do, and all of this. So all these, say something like this, there are every week assignments, lab and theory, and everything. So you will end up in preparing PPT and sharing it and all of that. Okay, so this is how you would be learning, and we will not be rushing it for sure. So we will make sure you learn each and everything step by step, and making sure you are actually progressing organically instead of uh, okay, I'm just skip rushing to complete the syllabus. That is not the case here. Okay. I think I wanted to show you guys this, so that like what you are going to spend, what you are going to learn in the next 6 months or say 5 months, and what you are going to actually how you are going to practice. So you have seen the tool, and once you kind of make the fee payment and then enroll the things, we will enable you the tools immediately. Okay, and for your information, we have all the synopsis tools. Okay, so and individual licenses you would be getting. Okay, because we procure licenses per individual. So and 24/7 access would be there, and no restrictions, unlimited access. And but remember, you would be monitored. So are you using it? If you are trying to misuse any of that, you would be caught immediately. So use it wisely for your learning purpose. There is no restriction for your learning and practicing and all of that. And I just showed you one design, and we do have multiple other designs which I would enable you guys as and when you make progress. Okay, so I think that's all I wanted to cover. Now I'm open for questions, if any.